This is my solution for the two sweeping servos problem in Palmer Quarter's picow class, lesson 99. If you're watching my previous videos, you know my setup was a little different last time. The one servo was powered by an onboard power. Now it appears that the servos are powered by Arduinos. And I'm using a picow and not a picow. This is a picow back here. The reason is that when I was practicing, I burnt up my picow and I burnt up the power adapter. Turns out the picow apparently can't coexist with that power adapter powering two servos. The power adapter must have malfunctioned and then caused the picow to malfunction. Anyway, I'm just not taking any chances here having separate power for both servos. Let's take a look at the program. The PIO program is exactly the same as my initial solution for lesson 98. I'm using the pull no block. It's the same program. Both of the servos here are being handled by this one program. This is all the documentation from the 98, so I'm going to skip over it. This is the slope and y-intercept, and I did reduce the slope to lowest terms. Internal method that computes a pulse width value for an angle. A couple of other constants. Here we define the two state machines. Notice they're both using PIO prog. One's using GPIO pin 20. That's the servo as you're looking at them, the one on the left. And the other one, pin 21, that's the servo on the right. All these other values are the same as they were in 98. This time we have to initialize two FIFO cues, one for the first state machine, one for the second. So here's the priming of the FIFOs, sending the period and the pulse width value, initial pulse width value. We're using 0 for the left one and 180 for the right one. Send in the period and the pulse width value for the second one. Now that they're on the FIFO cues, we have to go pull the values into the state machine registers. This pulls in the period, copies it to the ISR of state machine 0. Similarly for the pulse width, it's pulled into the OSR and copied to the X register. Similar thing is done for state machine 1 to pull in its period, same period, its initial pulse width value, copied to the X register. Then we activate the machines. The servo arms are going to have to reposition, so we pause for about a second here to reposition, and then we enter our loop. The loop looks pretty much the same, except we have two pulse widths we have to get, and two that we have to send, one to each state machine. Now you'll notice that in this first loop where we're going from 0 up to 180, I'm putting it on state machine 0 first and then on state machine 1. And in the coming back, I'm doing the reverse. And I only did that on the off chance the arms got slightly out of whack because of this order. I'm hoping that doing it in reverse will fix that, if it's even broken. So let's run it and see what happens. And there they go. Watch those servo arms. They had repositioned. Just going back and forth, back and forth. And I'll let them go for just another bit. I'm going to just keep going. So now I'm going to stop that one. And look at the second program. The second program is the same as that first one, but oops. Second program has a try except in it. So let's do that. You'll notice that I had to stop it using the red button. So let me just run it again. Here they go. I'll let it go for a second. This time I can hit Control C. And there they go. They went back. Let me scroll it down to the loop and let's see what the try except did. Loop was the same. The try except just paused to give the servo arms chance to stop. We're going to send them both back to 0 degrees. And we do the 2 puts, we give them time to position, and we're done. And it happened. All right, this last program is the same as the second program. It has a try except in it, but it took out the pull no block, so we're getting closer to the way Paul did at lesson 98 solution, and we're moving the side set down to this move instruction. The rest of this is the same. Slope of the line, function that gets a pulse width for an angle. Now here we have another function that wasn't in that other program. It says show TX RX counts. So you might ask, why is that here? Well, we're going to see. We have the same constants. State machines start the same way. We position them this way to initial angles 1 at 0, 1 at 180. We put the period and the first pulse width value to each of the state machines, and then we get them FIFO cues, and then we get them into the appropriate registers. And because we got rid of the pull no block, it's not going to get copied into the X register in either case. We activate the state machines, and again we sleep long enough to give the servo arms a chance to reach their initial position. We enter the loop. That's the end of the loop here. It looks pretty much the same. We get our angles, we put them, and in the going up loop, I do them in order: state machine 0, state machine 1, and then the pulls, state machine 0, state machine 1. And then coming back to 0, I do that in reverse order: state machine 1, state machine 0, state machine 1, state machine 0. For that same reason, make sure that the arms are staying in sync. So now I'm going to run this one. I'm not going to show you the keyboard interrupt yet. I'm going to run it. You'll notice it's running quite a bit faster than it did with the pull no block. I'm going to hit Control C. And notice down here we get some messages. So let's go see what happened in the keyboard interrupt. Let me pull it up. Keyboard interrupt happened. We stopped long enough in case the servos were running. moving. But now I've added some code. And why did I add this code? Well, I didn't have it before, and when I hit Control-C, the arms didn't move. They just got stuck. Had to think about it, and I realized that up in the, like for example right here, if you were interrupted after the puts were done, but before the pulls, you've done a put that's never going to get pulled if you get down here. So what this is doing is checking to see if there's something on the TX FIFO, and if there is, we show those counts, and then we just, while there's a entry there, we send a pull on in to the appropriate machine. So if that happened on state machine 0, we send them to state machine 0. There should only be one, but I'll put a loop anyway. And similarly down here for state machine 1. And we look down here, and sure enough, it happened. We got a TX count of 1, and it said the state machine 1 apparently got caught in between that put and exec. Okay, that's the end of this. Thanks for watching.